Good morning and good afternoon, everyone. Today we're going to be talking about how to use a compass. For those of you who've gotten a compass from school, we have what is called a safety compass here. A little bit different than that traditional triangle type of shaped one with the pointed edge, but this one here, no pointed edge. It is pretty nice. I do like actually using it because a lot of them come with measurements along the bottom and the top, so it doubles as a ruler. It also acts as a straight edge. So that idea right there is pretty nice in my mind. There are some gives and takes, though. If you're looking at your compass, a couple things that you'll notice. In terms of getting really tiny measurements, it's a little hard to find the holes and work them in the center here if you're trying to rotate them around versus, say, a normal compass where you can get your points really, really, really tiny. In most cases, though, we're going to have objects which are nice and long, which we can kind of use all the various points here. Another couple things to let you know before we get started as well, too. Whenever we're using our compass, technically we're trying to make something as precise as possible. We've talked about Euclid throughout so much of our course, and the geometry that Euclid and his team of people and academics and philosophers that existed around his time weren't necessarily using this, or they were using more like that original compass that you're more used to, or a piece of string actually tied to something like a pencil and then stretching out arcs. But with our compass here, it has a lot of benefits in terms of those flat edge, in terms of those measurements on the side. One thing that I would stress as well as a negative is in terms of the construction. These are like, $10 on Amazon or whatever. You're able to move the sides here, and what that ends up doing is slightly shifting over your circles. If you look pretty carefully, our circles here are relatively tiny, but then if we start to move our figure, we're going to be off about, say, half a circle, which is not necessarily a big thing because we're not building buildings, we're not engineers as of yet, but when we're going through and actually creating our figures, it can occasionally lead to things being marked down a little bit sloppy, for instance. So I'm going to show you some tips and tricks as we go along the way to try and stay nice and specific. So the first thing that we're going to do is copy a segment. In terms of our class definition, we described a segment as something slightly similar to, say, a line, but it has finality. It has a specific length to it. And what we're going to do today is create some segments, create some angles, copy them, and duplicate them. And while we're doing that, we're going to explore our definitions. So to copy a segment, first we need to create a segment. Normally I use this little guy here in the middle, which we can call the center of our compass rose, or some people call it the pinwheel. I usually use that to make my circles because I get a nice consistent size. It's going to be a little bit larger. And whenever I plot out my line, I want to go to the middle of the circle. So I try and always stay consistent. So if your measurements are off, by a hair, it's usually because our lines are slightly moved, slightly shifted around. So here we have an example of a segment which we'll just call A, B. If we wanted to measure its length using our coordinate plane, we can use something like the distance rule, for instance, or that shortcut associated with the slope we've talked about before. But in this case, we're going to use our compass. So there's two methods we can go about this, or two ways we can express it, and I find them to be relatively easy. Copying the segment is like our beginning level, if you will. So there's two different ways. The first way we can do is if we wanted to, say, transpose our segment right down here onto the bottom, what we want to do is create a new point A, which I'm going to do over here. Fill in my circle. I'm going to call this guy A prime because it's our new point, our copied point. And all we have to do to copy the length of this segment is we have to find which hole on our compass lines up. So what you'll notice if you're switching back and forth, essentially the circles along the top and bottom are augmented. They're off by half. So the bottom one should sit in on the point. The top one's going to miss it directly in the middle. whatever you draw your lengths as, it's just going to match up. I'm going to count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I like to just write down my values because I go fast and I forget. So I'm going to do here now is just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this arc I make here is equidistant. Any point here to here, any straight point from here to here or through the center is going to be that same length of 10. And that's where that idea of using like a pencil attached to a string and pointing it down and drawing arcs kind of works as well too. So wherever I draw my connection point, no matter where, if I draw it straight or diagonal, whatever spot it's actually going to land on and hit, I'm going to go right in that intersection directly in the middle. Fill in, and that's my point B. So any spot along this arc is going to be equidistant. So we have our segment AB, our segment AB prime, or our pre-image and image. Other examples you might see are like, how do you go about copying a segment onto, say, a line? And that itself, I find, is just as easy as well too. I'm going to erase some of my pencil mark away here. One tip as well as you go through, absolutely be using a pencil for sure. Particularly tomorrow as we get to drawing parallel lines and things like that, you're definitely going to make mistakes. And it looks sloppy too with pen. I'm going to draw a light pencil mark here. And once again, I measure my A. I slide it over. I know I have 10 because I wrote it down. I'm going to A double prime. And say I had a line and I just wanted to pop it on, or array for instance, I'm just going to go here. Going to line up my 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This spot right here is going to be my new B. My B double prime. All right, cool. Yeah, so that's it in terms of copying a segment. Our steps really are dependent upon like where we're going to mark it down. But our first step that we're going to commit to is duplicating A. We're then going to copy our length of our original segment AB, arc it out, and then label point B. One of your big pushes, at least for today, is going to be making sure to get your primes and double primes in there as well. But our construction that I'm going to be working on is a perpendicular bisector. Perpendicular, once again, is this notion of 90-degree angles, or the intersection of two lines forming four 90-degree angles. Bisector or bisection, bi, that prefix of 2, sector, cutting into pieces. We're going to cut our segment into 2 equal pieces at a 90-degree angle. To do this, what we're going to end up with is something looking a little bit like this. This would be an example of a nice convenient square, but what we're going to do is first create this bisection in the center and then connect our lines going around. All right, so let's look here. To practice this out, what I'm going to do here is make 2 points, and doesn't really matter where we're going to drop our line, but I'm going to make it nice and equal. I'm going to do a value of 10 here. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 spaces. If we were thinking about what the midpoint is, or where that bisection is going to occur, that's going to occur basically, 10 divided by 2. It should happen at the 5th line. 1, 2, 3, 4, 5. Somewhere around here. 1, 2, 3, 4, 5. So we got our midpoint is going to be about right there, but I'm going to prove it to you. The way that we go about that is we're going to create a system of equal arcs. We're going to kind of take that same idea of measuring out our segment. We're going to find a space that's about 3/4 of the way down our segment. So past our halfway marker, 1, 2, 3, 4, 5, 6. I'm going to go here. I'm going to make a nice arc of 6 along the bottom. I'm going to slide up here. 1, 2, 3, 4, 5, 6. I'm going to make a nice arc up here. What I'm going to do now is take that same number 6. I'm going to go to my next point. 1, 2, 3, 4, 5, 6. And I'm going to cross it. Cross it right along the bottom. Come around up here, lightly crossing up here as well. And what we'll see is we have where these arcs intersect one another. We have a line that we can use to draw straight down. And that intersection, as we see, follows our lines, creates a nice 90-degree angle, but it also hit right there in the center, which is super cool. The reason why this works is because we're doing all these different arcs, but all of equal value. Essentially, we can kind of connect our points here, if we will, but all these arcs are all equal distance. So if we're going to split that equal distance in half, we're going to end up in the middle. So let's take a look here. Well, we can describe here, we can go ahead and say we got A, comma B. What I like to do now is as we go around, if we did our drawing, here perfectly, essentially we have 4 congruent pieces as well. Depending upon where your intersection is, you're either going to create something like a rhombus, which is a 4-sided figure with 4 congruent sides, or you create a square where we have 4 congruent sides and 4 equal sides as well too. Or sorry, perpendicular. Alright, so this figure here we can describe one last time. If we label our midpoint here, we can go ahead and say that AM is equal to MB. We can manually count that out. We can also go ahead and say, notate our figure as well too. These sides here are now equidistant as well. Okay, our next figure we're going to look at here is going to be an angle construction. We're going to create our own angles, and by the end of this short section, we're going to be able to copy that exact angle. So let's take our compass and let's create some angles. So first thing we're going to do here is, in terms of space, we're going to need, however large you draw your original angle, you're going to have to duplicate that along the bottom. So I'm only going to make mine about, say, 4 or 5 boxes high. Trying to keep it in the camera angle here for you. First thing we're going to do, plot our point, our vertex. Which I'm going to call X. We're then going to draw out the other portion of our angle. And when I'm practicing, I like to kind of use almost like a vector, like I know my slope of my angle here, so I can kind of double check my work, if you will. All right, our first step that we're going to go ahead and do is going to be drawing a ray along the bottom. What we want to make sure is that we have enough space to duplicate our angle here. I'm going to slide just down here. So this ray can be of any length. It's just the bottom of our angle. Be in any direction if you want as well. But I'm going to have my x and x prime, or my x angles. First thing I'm going to do is create an arc and mark it down on my line here. I'm going to go ahead and use my fourth point. So if I'm using my graphing paper, I know it kind of goes about 1, 2, 3, 4, 5 boxes. If I go over here now, duplicating that arc once again, should get about the same. And what you'll kind of notice is just from where I put my compass on this x value and this x value, my line is slightly off by maybe a couple millimeters. It's visible, if you will. But I'm going to go ahead, duplicate this whole arc here, duplicate that whole arc over here. And now what I want to do is go ahead and label my points of my intersections. And I'm going to do a measurement now from Y, that top portion, down to the bottom, and I try and find the circle which matches. So this time it looks like about my third one on the bottom, 1, 2, 3. And what I'm going to do is go to this arc now and duplicate that same measurement. I'm going to find where it hits. So I have my Z prime, my Y prime now. And if I go ahead and go from the center of my point, try and hit the center of that intersection, which means you're going to leave enough space for your pencil to come past the compass. So the pencil point itself goes over that intersection. And if we look here, we have about that same exact amount of space gets generated. If we're going to use kind of our eye, we can kind of see go down. These angles are matched up. If we did our distance formula, theoretically, or that copy or line segment, it should be about the same exact length as well too. That's 1, 2, 3, 4. About 1, 2, 3, 4, and we get a nice duplicate. So kind of reiterate our steps here again. We have our angle. We plot out a nice ray along the bottom. We then have to go ahead and measure our arc for Z. So we create an arbitrary arc. We find that measurement, copy it all the way through, label our points, come down here, plot that Z arc all the way around. We then now find out the relation not between X and Z, but between Y and Z. So we go ahead and copy that measurement and then duplicate it up here. Wherever that intersection occurs, we draw our line through, and we get our copied angle. So these are going to be our first set of constructions associated with angles. What I'd like for you to do is, while you're practicing on them, really all you need to do for today is just in your paper, go through, draw out just, a random, say if you want to practice your angles, you can have like your brother, sister, aunt, uncle, mom, dad, whoever, just draw some random values into your book. A nice thing would be, if you're using graph paper, to not use the lines as well. It's going to force you to kind of practice those steps. And just go through and keep doing it. If you have questions about these constructions as well, on Google Classroom, I provided a kind of step-by-step process for you that you can use for creating your constructions. Personally, myself, the way that I learned the constructions, I use those notes that are on Google Classroom, but I basically just manually did it over and over again and tried to learn that concept of why things work. That, I think, is pushed by this idea of our angle, where we're measuring the relationship between x and z and y and z. And that allows us basically to form a triangle, or a perfect triangle, which allows us to then copy the angles in that triangle. At least that's how I look at it. Tomorrow you're going to be doing some other stuff related to constructions, a little bit more detailed in terms of creating parallel lines and different forms of translations. I personally like doing those. I think they're kind of fun to kind of copy other stuff down. It's more steps, but the idea works. If you do have questions, though, please feel free to email me. On Friday, certainly after school, we can hang out and go over some of these, but really practice makes perfect. Before you try and ask me, try and literally do it. Try and do it 5 to 10 times to see where mechanically you're making your mistake. And then from there, reach out and kind of, either write those steps down in terms of what you understand, talk to a friend, or of course email me as well. But until next time, please stay safe, wear a mask. Be safe. Better be safe than sorry.